Okay. So I'm back to WebAssign. I'm sharing my screen. I want to go to 2.3 if it allows me. Please allow me. Yes, right here. Okay. Okay. I would like to start with a fraction. Okay, let's start with 14 and feel free to choose next one if you'd like. So 14 in 2.3, and we have limit as x approaches -3, x squared plus 3x over x squared minus x minus 12. Perfect. Josh, will you tell us what would you do first?
Let's see. Will be factor?
Absolutely. Thank you. You could have said plug in, which would have been fine. But you said factor first, which I highly recommend. I'm not against plugging it in first. Maybe you plug in and you get 2/3 and you're done. You don't have to do anything else. You don't even have to factor it. But those cases are rare. So thank you for saying that. Yes, I highly recommend immediately factor. Okay, perfect. So limit as x approaches -3, because I need to explain or refresh your memory on something. Okay, Mark, will you give it a shot for us?
Yeah, for the factoring, it's going to be x, and then parenthesis x plus 3,
Great
parenthesis.
job. Yes?
And then on the bottom, it's going to be parenthesis x plus 3, parenthesis x minus 3. Or 4, yeah.
Good. So because it's x squared and minus x and minus 12.
Yes.
Okay. Now, I need to talk about a theorem from your past experience with math, which is extremely helpful and it will help us moving forward with limits. It's called the factor theorem and remainder theorem. So two theorems together. I couldn't hear you. Was it for me? Okay, you are muted. So the factor theorem and the remainder theorem. So if I have a polynomial divided by x minus 1, p of 1 is the remainder. So if I plug in 1, I will get the remainder. If the remainder happens to be 0, if, that's a big if the remainder, when I plug in this function, this number, what if I have x plus 3? Then I have to plug in -3. What if I have x plus 5? Then I have p of -5. What if I divide by x minus 10? Then I have p of 10. If the denominator is this and I get 0, or this and I get 0, or this and I get 0, and so on and so forth. What does this mean? And let me help you with a numerical example. Is 10 divisible by 3?
No.
No. So here the remainder is 1. But is 9 divisible by 3?
Yes.
Which means the remainder is 0. So what I'm telling you, when I divide this polynomial by x minus 1 and I get the remainder to be 0, or I divide by this and I get remainder to be 0, what does this mean?
It means there is no remainder.
It means that x minus 1 is a what for p of x?
A factor.
Yes. The same with x plus 3, the same with x minus plus 5, the same with x minus 10. So if I show that when I divide by a polynomial of this kind, if I show that the remainder is 0, then I know x minus 1 is a factor of p of x. The reverse is also true. If when I plug in 1, right, and I get 0, then x minus 1 is a factor, right? So, coming back to our problem, you can say, it's already clear. You already have the factors here. Yes. So, if you had said plug in, I would have shown the reverse situation. You plug in, you get 0 over 0 because it's very clear. You're going to get 0 over 0 when you plug in negative 3. So then x plus 3 must be a factor that disappears from the top and bottom. Why? When you plug in x equals negative 3 in the top and you get 0, it means that this, according to our factor and remainder theorems, it means that this numerator has a factor of x plus 3. When you plug in negative 3 and you get 0, it means that the denominator has a factor of x plus 3. So this factor of x plus 3 being removed, not always, but we expect the factor to go away and the limit to exist because the factor went away. It's not guaranteed. Remember, I never said that 0 over 0 will exist as the limit. I said it has potential. So I can show you examples in which you remove the factor, but there is another factor that is another x plus 3 that will still give an undefined situation. But in this case, it's a nice and clean situation. Can anyone give us the numerator? Where does the numerator go? So now I can use the limit law. The limit of the top and the limit of the bottom. What is the limit of the top? Derek?
Negative 3.
Excellent. What is the limit of the denominator? Nabiha?
4.
One more time.
I'm not sure.
Sarah?
Would it be negative 7?
Very good. So when x approaches negative 3, x approaches negative 3, we had one of our limit laws. The one that I said is not really a limit law because n here can be 1. So the limit of x when x approaches a is a. So, or the limit of x minus 4, same thing. So negative 3 minus 4, it's negative 7. So the limit is 3 over 7. So the limit exists. Any questions? So if you had said plug it in, we would have obtained 0 over 0, and we would have analyzed in this way. What do I expect to get rid of? Of course, I expect to get rid of x plus 3. When x approaches negative 3, x plus 3 approaches 0. Guaranteed. So this is what I was hoping to get rid of. Once I did, the limit existed. But if I could have a situation like this. So limit as x approaches 0, let's say, from x over x squared. Say the top goes to 0, the bottom goes to 0. Oh, the limit exists. Not so fast. Because I remove a 0 from the top and a 0 from the bottom if you want, but then it's still DNE. Because I could not remove the 0 in the denominator completely. So not all 0 over 0 end up existing. That's why I always say it has potential. Okay, back to sharing my screen. Any questions? Okay, so we looked at a rational function. Let's look at a radical function. So please choose. I prefer choosing the even numbered ones because then you can do the odd number ones, and this is highly recommended. So please always, after you rewatch the videos, or at least part of the videos that you need, always, if I select problem 22, make sure you do 21 and 23. If I select 26, make sure you do 27 and 25, because most probably they're very similar, and check the answer in the back. This is the only way I can do anything for you, but if you don't come halfway, we're not going to be able to make progress. And I really, really care about your progress in my class, and you as in any individual in my class. Okay, so I know I talked too much. What was I saying? I was saying to select either 22 or 24. Please choose.
Can we do 24?
24 it is. Okay, I'm gonna, no, I can switch back before I copy the problem. So let me copy the problem first. What was it? So where is it? Okay, limit. So this is 24, limit as x approaches 2 minus x divided by the square root of x plus 2 minus 2. Now I'm switching. Okay. Well, even if you say factor here, all I would do, and I will factor, will be this. Always remember descending order. No negative leading coefficient. You can say, I can deal with those without you doing this. Fine. I'm fine. This is my recommendation. I'm not asking you to switch to my method unless you feel it's easier and you understand it better and it works for you. But whatever you show, please make sure you show everything in writing, though. Okay, so what do we do next? Mickey?
Question?
What do we do next? What is our next step?
So you plug in 2.
Yes, yes, yes. So the top goes to?
It goes to 0.
Great job. The bottom goes to?
0.
Right. Which factor we know we have to get rid of? At some point in time.
Sure.
Okay. And this limit, which factor did we get rid of?
X plus 3.
Great job. Thank you, India. So one more time here, which factor we need to get rid of? For sure, guaranteed. X minus 2. So see, with this limit and understanding what's happening here, we are a mile ahead already. We don't know what the answer is going to be. I have no idea. But I know for sure that if I don't get rid of this from the top and from the bottom, I have an error somewhere. Okay. So now I cannot do anything to the top. Anyone suggests anything from our past in algebra?
We should rationalize.
Great job. Thank you very much. Who said so? Jordan? Okay, thank you. Great job. Thank you. Rationalize the denominator. Okay, what do I do?
That's going to be multiplied by the conjugate.
Very good. Who was that, Mark? Thank you.
Yeah.
X plus 2, the square root of x plus 2 plus 2. Great job. And you're going to learn very soon that I always run out of room. So don't get upset. I always run out of room. I don't know. I write so big, I guess. Thinking that maybe you can't see. And then I always run out of room. But that's okay. I have plenty of paper. Okay, good. So then we have limit as x approaches 2. The minus stays. The numerator, it has an x minus 2. Can anyone give us, and also the numerator is also x plus 2, the square root of x plus 2 in parentheses. Can anyone give us the denominator?
X plus 2. Plus 2.
Careful. A minus b times a plus b. A minus b times a plus b.
A squared minus b squared.
That's it. Good. So then what do I have in the denominator?
Minus 4.
Very good. Do we all agree? Everyone? Great. Okay, moving on. Stay with me. We don't know what's happening, but I know that I have to get rid of this from top and bottom. I have no idea. Honestly, I don't care. I know I'm looking for this. Top and bottom has to go away. Okay, when x approaches 2, negative. The numerator has x minus 2, has the square root of x plus 2 and plus 2. And now can anyone give us the denominator?
X minus 2.
Can anyone tell us what to do next?
Cancel out x minus.
Of course. Of course. As expected. We knew this 10 minutes before we even got here. 10 minutes ago. Okay. So now can anyone give us the answer? Javon?
Square root of x plus 2 plus 2.
Okay, very good point. One other thing that I kept forgetting to tell you. Thank you very much. Thank you. See, this is the original limit. The limit operator is there. When you write the next step, if you drop the limit operator, I will not be able to give any credit. The limit operator disappears only when we apply the operator to the function. Here we did not apply the operator to the function. Here we did not apply the operator to the function. The function now is x over x minus 4. We are applying the limit operator. That's why it disappears. This is like saying, this is, don't, sorry, forgive me. I just want to say one more thing. So when I apply the square root to 4, I do not write the square root of 2. No. I already applied the operator. That's why the operator disappears. So now I apply the operator to x over x minus 4. That's why the operator at this stage disappeared. So coming back, in order not to confuse, I'm really hoping that you're going to watch this or at least look at the notes or something. I'm hoping. So now we started with the limit. The limit operator is there. 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 Now we're applying it to the function. The limit operator disappears, and I need the number.
It's 4.
So it is 4, but with minus in front. So you apply the limit operator here, and 2 plus 2 is 4. The square root of 4 is 2. 2 plus 2 is 4 indeed, and there is a minus in front. Great job. I like to move on. Let me know if you need other examples. Let me look again and see if you... I'd like to move on. Do we have any difficulties with 2 to negative 1 and negative 2 plus h to negative 1? I hope we don't. Do we have any situation here with finding the least common denominator? And I'd like to move on to the squeeze theorem and a function with absolute value. Where are those? Right here. So I would like, we need to choose something from absolute value. Okay, last chance. Yes, no?